the way I look at it is always from external go back to internal instead of internal go out to external, meaning you look at the market, you look at what the competitors are doing, you look at how customers buy things. Who are your customers? A good example would be if you think of a contact center or customer engagement solutions, there is the automated services or self-service. Basically, a human, an end user, reaching a customer care or a sales hotline or sales live chat, right? And the other party is actually a machine, not a human being. So a long time ago, it used to call IVR, but these days it can be a voice machine response system. It could be a chat machine response system. It could be a social messaging, response system. So it's omni-channel. But that is part of the solution. So that is what we call self-service or automated services. And then there is the solution product we have that is assisted services, meaning you actually need a live person to provide service or help to our customer, right, the end user. In the Oceana world, we don't separate them. It's inbound, outbound, automated self-service, assisted services, workforce optimization, reporting, analytics. They're all together as one solution, not 10 different point products. And the way it was built many years ago is very monolithic. It's just the way things evolve. And these days, if you want to move fast and you want to be able to leverage the cloud architecture, which is horizontally scaling and be able to dynamically flex up and flex down, you cannot use a monolithic system. Meaning, if you have a really large systems and you want to be able to scale it out, that means you have to replicate a really large system many times across multiple different data centers, right? Amazon Cloud, for instance. And it becomes really expensive. Yeah. So the way to do it is build microservices which break down the code into very small components. Now, we had the concept many years ago, if I recall, probably 10 years ago with the concept SOA, Service-Oriented Architecture, which is exactly kind of the same concept. But 10-15 years ago, SOA, the reason why it didn't fly is because even though it's a great concept, you need the cloud to self-support it, right? And you need a very modern API interface. API is a way for a program to talk to another program. So typically, if you have a lot of microservices, if it's a standalone microservices, but you don't have the API layers, you can't use it. So that means you need to wrap each of the microservices with the API layers. And it has to be a very modern API. So what does that mean? Your microservice has to be modern and lightweight from a talking protocol perspective, right? So microservices, the properties, the two big properties would be, one is very modular, can stand alone. You don't need like A, B, C, D, E to get E. E itself is standalone, it can work. Second is it has to be a lightweight, modern API around that. Typically they speak HTTP, which is an internet protocol, or HTTPS, secure HTTP. If you have those properties, you are considered as a microservices vendor, right? Or companies that build microservices. Now, where are we in that, right? About 2-3 years ago, we came up with the concept of Breeze, the platform, and the concept of snapping, which itself is a very modular application that we can plug into Breeze, right? We call it snapping. The snapping today is very modular, so it has a lot of the microservices nature. And each of the snapping has a RESTful API, which is another programming language that wrap around it. So in a sense, it is considered 70% there from microservices. So from a customer perspective would be the ability to further enrich the usage-based consumptions. Because if you have a microservices approach, you can definitely scale out and spread out your solutions across different nodes. And this aligns with the cloud infrastructure, because you do need to have a way to scale out. So if you translate that into financial metrics or business metrics, it is a higher level of reliability because it's spread out instead of monolithic. it is easier to do update and change. For monolithic system, one feature change, you have to test the whole system. From a microservices, because it's already broken out into small components, if there's a feature change in component A, you don't impact B, C, D, E, right? You don't have to like take the whole thing. So the agile development process, it helps a lot, right? Because each individual microservice can be managed by a team, rather than you have a monolithic software, then you have to coordinate among R&D teams to, if you and the testing, the whole thing is become much more complicated because it takes longer cycle to test the whole monolithic system again compared to making sure that these microservices work. As long as your API is backward compatible, right? The whole testing cycle is much more risk-free, or perhaps less costly. Let me just put it that way. So the speed of innovation, the ability to do the reliability because it's spread across. And third is, if it's a microservice, that means it's much more granular. So there are certain functions or services you don't use, you shut it down. There are certain services you want to use, you spin it up. So you don't have to spin out. Let's say your software contains like 30 functions. In the olden days, you have all the 30 functions up and running. So if you put it on AWS, you have to have the resources enabled for the 30 functions.
And you pay.
And you pay, right? It could be $10,000 a month. But you only use 2 functions and you're paying for 30 functions because it's monolithic, you cannot turn on and off like that. But if you have 30 functions in 30 components and you're able to turn down 28 and just give that 2 functions up and running, you pay for only those consumption of that 2 components, you literally save a lot of money.
Absolutely.
On a per month basis, right?
Yeah.
So there's a technology talk, but it all translates to a real benefit, ROI, to the customers.